I'm Willow Chandarina. I'm on the Elastic File System team. You've been hearing a lot today, a lot of great content from James and Chris about how you can use S3 with your serverless functions. We're going to take a quick detour for the next half hour and look at some of the use cases where you might want to use Elastic File System or a shared file system with your serverless applications. So we're going to talk through, starting out with what is EFS? What are the kinds of use cases where you might want to use it with your serverless functions? And then we're going to get into the more practical bits of how do you actually do it? So how do you set it up? How do you set up your file systems and your functions to talk to each other? How do you set up permissions and stuff like that? And then before we get to the end, I'll talk through best practices so you can make sure that you have all the information you need to make sure that everything's running just the way you want it to. So let's start with when would you want to do this? In the first session today, Paul did a really good job of just introducing why you'd want to do serverless compute. So I'm not going to go deep into that again, but I'll just summarize by saying customers that use serverless compute get three main benefits out of it. First is they get a lot more agile because now you have a compute infrastructure that can scale up and down with the load of your applications. Next is you can get faster time to market because it's easier and faster to push out new code changes with things like continuous integration and continuous delivery. And last, because you're handing over more of the operations of your application to AWS, your applications get more reliable, your operations get simpler, and ultimately you save some cost as a result. Now, there's no shortage of choices for what compute services you can use on AWS to launch your application. We have, on this slide alone, 2 services that are serverless, Lambda and Fargate, as well as a couple of services that aren't. The point of this slide isn't for me to sell you on a particular way of creating your application, but instead, just to point out that we have lots of options, each offering a different layer of abstraction for how you create your application. And what you might find is different applications or different parts of your application lend themselves better to one thing or the other. So the key takeaway here is when you use shared data, whether it's S3 or EFS, it can be the thing that ties together the different pieces of your application that may be running in different compute services. So data makes it simpler to pick and choose what's best for any given piece that you're building. So now let's talk about what EFS is. So Elastic File System is a simple serverless shared file system for your compute applications. So just calling out a couple of attributes of it. So as the name suggests, it's a elastic service. So you create a file system and you don't pay for anything until you start putting in data. Your file system auto scales with the amount of data that you're storing, and you only ever pay for what you use. It's a serverless service similar to S3 and Lambda Fargate, meaning you don't have to manage any servers. We handle all of the management and administration. You handle just your application layer and the policy management. Amazon EFS is a regional service. And when we talk about a regional service, what we mean is when you write data to EFS, we persist your data to at least 3 availability zones and make that data available from all availability zones in the region, at least with EFS standard storage classes. I'll talk in a minute about other storage classes we offer that will hold your data in a single availability zone, which might be right for some applications. It's a shared file system, so you can share data between 1, 2, all the way up to tens of thousands of applications. So the concurrency of up to tens of thousands comes in handy whenever you have a Lambda function that may need to quickly scale out and process a lot of new images or a lot of new events that are coming in. EFS offers high performance, gigabytes per second of throughput, tens of thousands or 100,000s of IOPS. And like I mentioned before, we have multiple storage classes that are each optimized for cost, performance, availability, durability. So you can pick from those on what's best for your application. So let's just start from the basics. When what are the core reasons why you might want to use an EFS for your application? So we'll get into specific use cases in a while, but fundamentally there's two reasons. One is you need to share data, and that's share data between parallel instances of your application. So this could be invocations of a Lambda, this could be multiple Fargate containers that need to share the same reference data, or it could be sharing data between applications in your infrastructure. So sharing it between a couple of different web servers, or a web server and a backend server, or something like that. The other reason why you might want to do it, even if you don't need to share applications, is because you want to make your application a regional application. So like EFS is regional, you may want your application to be able to fail over between availability zones or run in any availability zone in the region. And because all of your data is saved at the region level and available from all AZs, it makes it really easy to build those kind of applications with EFS. So again, either sharing or to make your application regional. Now, I mentioned a lot of the key attributes of EFS. Now, we've already talked today about the key attributes of Lambda as well, of Fargate. So when you put these services together, a lot of those benefits and attributes stack on top of each other. So the simplicity is one key benefit. When you're working with all serverless services, you now have an infrastructure where you don't have any hosts to manage, which makes it really simple. And also EFS, when you integrate it into your environment, really any operations you do on EFS are as simple as opening files, closing files, writing files. It's the same thing that you would do if you were writing to local files inside your application. So it becomes really simple to get started with and use for your application. The availability and durability of EFS pairs well with the regional services of Lambda and Fargate. So now you don't have to care which availability zones your instances or your invocations or your containers spin up in, because the files are everywhere. All of them are elastic, so you'll only pay for what you use, and they're elastic in separate dimensions. So if all of a sudden you have a bunch of new data, you just need to scale out your file system. If your data stays the same, but your load goes up on your API, you scale out the compute. So they're independently scalable, and everything is nicely right-sized for what you need. And we built these in a way that they are securely integrated with each other, both through IAM-based authorization and through EFS access points, which, similar to S3 access points, are a way of ensuring secure access to specific applications. And I'll get into how all these things work in just a little bit. So now let's get into some of the specific use cases of when you would use EFS and serverless together. So first, we see a lot of customers running content management services, and specifically customers that want to start doing serverless content management. And the main reason here is it just makes this really simple. So first, why would you want to do content management? So this could be, like, if you're doing internal stuff, it could be blogs and wikis that you keep inside your company, or it could even be the homepage for your company, the external facing homepage. And what's simple about this is because there's already off-the-shelf engines that allow you to build this. WordPress and Drupal are a couple of examples. You can take those and take all of the functionality that they have to offer. So templates, plugins, built-in SEO and social media and things like that. And simply just run them on AWS services that provide a serverless experience, EFS being one of them. We have reference architectures on the website for how to run several of these. Most of them look a lot like this, where you take the off-the-shelf content management system, so WordPress in this case, you put it behind an application load balancer, and now you have a regional version of that. So you have instances of that CMS in multiple availability zones that share data, so share the template data, they share blog data, uploads, things like that in the form of Amazon EFS, which, as you can see here, is a regional service. There's often a database component as well, so you can throw in Aurora Serverless, and now you've using Fargate, Aurora Serverless, and EFS, you've now created a full serverless stack to run that content management system in and really simplify the process of running it. I've got a couple of case studies in these slides. So the one that's relevant here is with a company called Aquia. Aquia is a hosting provider, so they have a managed version of Drupal content management service. So customers use them to host and manage their Drupal-based content management systems, websites, things like that. And Aquia recently modernized by moving on to EKS. They use EFS and Aurora Serverless, and they really simplified their overall architecture by using these serverless services and enabled themselves to scale up and down much easier as an individual customer of theirs had load increases, load decreases. Another use case here, and I think it was one that came up in the chat, is machine learning. So with machine learning, of course, there's two parts of machine learning. There's training your machine learning models, and that's something that often happens in parallel in containers using a large amount of training data. So you can, and lots of customers do, have their training data in EFS, and then they load up their training job in containers. The output of that is a ML model file. And what a lot of customers want to do once they have that ML model file is serve it. And serving it means having an API that can serve result ML lookups. So for any given new data coming in, classify it, make some prediction based on it, something like that. And Lambda is a very attractive service to use for those because Lambda scales down to 0. So if nobody's calling your inference API, you're not paying for anything. And then if all of a sudden a lot of users call that API, you want to scale out quickly. Now, a lot of these ML model files don't fit in the Lambda temp space because they're larger than 512 megabytes. Or sometimes the models almost fit, but then you have libraries like MXNet or TensorFlow that you need to import into your function as well. And what a lot of companies are finding is that EFS provides the overflow space needed to run these ML inference applications in Lambda. So we see here that EFS can help out with both sides of those. So you can first train your models in containers, and then containers put them in, and then you serve them through Lambda. And EFS kind of handles making it easier on both sides. One example of a customer that's using us for that is Asurion. So Asurion, for those of you that don't know, is a company that sells extended support contracts on consumer electronics. And because of that, customer service is super important to them. They have a call center that their customers call into if they need help with their warranties. And what they wanted to do was use machine learning in order to figure out how good their customer experience was in their call centers. So they had these large audio files for each of their calls, and they wanted to use Lambda to load that audio file in, compare it to the ML model that they had trained on, whether it was a good call or a bad call. Was the operator enthusiastic, or were they rude, or something like that? And those audio files didn't fit into Lambda temp space. So they were trying to do this about the time that we launched the EFS integration with Lambda, and it enabled them to give them enough space to store those both the model files and the call recording files, and then build their ML inference function. Next use case is data pipelines. So this is something you can use with EFS and S3. And this is just simply data comes in, you want to pass it through a couple of different stages before putting it in its final spot, whether that final spot is Parquet files in S3, whether it's putting it into a Redshift data warehouse or something like that. The key thing here is EFS can especially help out if those pieces of data that are flowing through are really big and you can't download them to temp space every single time. So an example of a customer that's doing this is Skywatch. They have a data pipeline that takes satellite imagery from S3, passes it through Lambda Functions to chop it up, to identify different features in the image, and then ultimately to serve it to their users. So EFS helped them adopt Lambda for those as well. And the last thing, and this is kind of a general category, is a lot of customers are looking to use Lambda, kind of on-demand Lambda functions as a way to do other miscellaneous file operations on a file system that's being used for something else. So imagine, for example, that you have a content management system using EFS. You can attach a Lambda function to do virus scanning on new uploads coming in, OCR on resumes coming in, or even do periodic data maintenance of figuring out how to charge back your actual users who are using that content management system, deleting data that may be older than some threshold. All these things are possible now that you can attach a Lambda to a file system. So that's a little bit on why you would want to do this. Let's talk about how to actually get started. So we're going to talk through security and identity, how to make sure you get that right, performance optimization, cost, data protection. So for security and identity, basically, there are two main goals here. One is to make sure that your file system can only be mountable or accessible by the applications that need it. Pretty basic. And two is once your application accesses the file system or mounts the file system, it should only have access to the data that it needs. So this is if you're sharing a file system between multiple applications, each of those applications should have the right permissions in a fine-grained manner. And we solve both of these. So let's talk about how. So the first problem of how do you make sure that you can authorize specific applications to your file system is solved by IAM Authorization. So we launched this a couple of years ago now, the ability to use the IAM role of your application, whether it's a container or a function, to authorize it to access EFS. And the way this works is when we set up the initial TLS tunnel between your application and EFS, it passes your IAM credentials, and then you can, it'll compare your identity policy on your role to the resource policy on your file system to decide if you're A, allowed to mount in the first place, B, whether you're allowed to write any data. So you can have read-only or read-write access, and you can also decide whether you can read or write as the root user, which in some cases you may want to do, other cases you may not. So you can control that through IAM. Next, once you get into your file system, all of the individual permissions to the different files and directories is controlled by POSIX ownership, POSIX mode bits. Now, when you add in new serverless applications, some of those things may not work the way that they used to in the old world. So specifically, let's say that you attach a container to your file system and you're launching a off-the-shelf Nginx container image or something like that. Oftentimes, what that container would have been built to run as is root, because there's only one user in the container. Who cares what it is anyway? It might as well be root. So then, once that application tries doing operations in the file system is going to treat that application as root, whether you want it to or not. So really the thing to understand is by default, the POSIX identity of your application comes from the container image at build time, not the actual runtime of the tasker pod. By default, we'll talk about how to fix it. Then when you add Lambda function to this, really Lambda was built native to IAM. There is no real POSIX identity to speak of. So it's non-deterministic. So you really can't use it for this. And it's to solve this identity mismatch issue why we created EFS Access Points. So to understand what an EFS Access Point is, let's read through what the policy is and then talk about how that's used. So when you create an EFS access point, there are two things that you define. One is called POSIX user. So here you give it a UID, a group ID, and if you want to, some list of secondary group IDs. When you create an access point with a POSIX user, the point here is, what you're saying is, any application that uses this access point is not the user that they think they are. So if it's a container running as root or a Lambda function running as who knows, they aren't that user ID on the file system. They're this user ID on the file system. So this makes sure that you have control over how an application reads and writes data in your file system that doesn't depend on what the application says it is, which is super important. Next, the access point can root that application to a directory other than the file system root. So this allows you to create a private space for each application within the file system, or at least make sure that the application isn't coming in to see data where they shouldn't be. And there's an extra thing in here called creation info, which is not only do I want this application to be rooted at this directory, it doesn't exist yet, and this is how I want EFS to create it. So again, access points enforce file system identity, so they let you choose what an application can do on the file system rather than letting the application choose. And it can route those applications to a specific directory and even create it for you. So now you don't have to do any external provisioning. So again, how it works, your application can be running as root for all we care. It's going to pass through that access point, and it will be the user ID that we say it is in the access point. And to make sure that applications mount the file system with the access point you want it to, you can use the IAM policy using condition keys. So you can say this application or this IAM role can mount this file system, but only using this access point ARN. And the approximate syntax is there. Check the docs because I'm missing a few curly braces for space. So now, one of the things of this talk is how do you share file systems between different applications? So there's really two ways that you can do it. One is just share the access point. You create an access point. That access point has some identity in it. You can mount that access point from any number of applications that you want. And you would want to do that in the case that each of those applications has identical access to the file system. There are other cases where you want applications to share data, but not exactly in the same way. You want one user to be able to read and write, but another user to be able to read only. So in that case, you can have two different access points, each with a different user ID, but the same group ID. And then you can use user and group permissions to control how they differ with how they access files and directories in the file system. So now let's talk about, that was kind of a lot of intro on how to set up authorization, stuff like that, but that's typically the most important thing to know when you're attaching to your EFS to your application. The rest is pretty easy once you have that set up. So with Elastic Container Service, I'm not going to show all the different ways, but basically what you're going to do somehow in your container definition is say that you want to mount a volume. That volume type is EFS. There's a file system ID. You give it your access point ID, and you add it, and then it just mounts it under the hood, and then you can read and write data in your file system as if it was local at the path that you mount it to. With EKS, what we do is we integrate with the container storage interface framework. So we have an EFS CSI driver that we vend, and there's a lot of different concepts with CSI that are outside of the scope of this presentation. But the one thing I want to call out here is we're about to launch a new provisioning mode within the CSI driver that I wanted to share with you called dynamic provisioning. We're really excited about this because it makes it really easy to get EFS set up in a Kubernetes cluster. And basically the way that this is going to work is you have users come along and they're going to be launching an application that wants file storage. They are first going to create what's called a persistent volume claim, which basically says, I want some storage for my application. That request is going to go to the driver. The driver is going to have a service role on it that makes it allowed to create file system resources on the user's behalf. So it's going to turn around and go to EFS and say, I want to create an access point with a unique UID, unique group ID, and a unique directory. So it's going to create a private space inside a file system and expose that to Kubernetes through a persistent volume. So every time you do this, a new access point is going to be created, and that access point is going to be assigned to the application. And users just, as a result, dynamically allocate what they see as logical file systems for their applications.
So Will, do you hear me real quick?
Yeah.
It's Chris Munns here. We jumped in. We, in desire to keep this live here, we've got a bunch of awesome questions for you, and Robert joined here as well. And maybe you cover some of this here in a little bit, but there was actually, I thought, a really, really interesting question from Joe, or about, from JamLows3. What are the different methods to increase parallelism for ML workloads? Or I think general question around better throughput for EFS, or any like ways to think about throughput in EFS.
Sure. Yeah. So when you have a Lambda function attached to your file system, let's say that you are doing ML inference. So there's a model file, and you want to scale out around that model file. Throughput is key, because every time your Lambda function scales out, you're going to have to pull that model file at least once into each of the containers running your Lambda function at each cold start, basically. And the best way to give more juice to that is by configuring provision throughput for your file system. So you can configure up to 3 gigabytes per second of aggregate read throughput for your file system, and then that will get spread across your Lambda invocations. But again, the key thing to keep in mind here is you only need to do it at cold start. Once a Lambda container reads a block of data once, it keeps it cached. And then the next time you get a warm start invocation on that same container, it's super fast.
Yeah, I'm going to drop in here a link to some information about the EFS throughput models and all the deep details that we have here in the EFS documentation. I think there's some awesome stuff there.
Great. Were there any other questions you wanted to go through while we're at it?
I don't think we have time for any more questions here. We're running a little bit behind schedule. I'm going to have to keep the program moving right along. Will, do you want to close out the segment with a couple more key highlights here?
Let's see here. Let me just go through real quick. So really, as we're talking for best practices on security, use the stuff I talked about. Use IAM, use access points. I want to draw everyone's attention to recent performance enhancements. So we have 5x'd our IOPS, doubled our per client throughput, tripled our read throughput lately, and our latency is 3 times lower than it was before for small file type workloads. So I'd encourage you to check that out. If I had more time, I'd get into that. Last thing that I'll call out is to optimize your cost with EFS, make sure you turn on infrequent access. It can lower your storage cost by up to 92% by tiering off less used data to lower cost storage. We recently launched EFS one-zone storage classes, so now the cost is 47% lower for any use case that is okay storing data in a single availability zone. So I'd encourage you to check that out. And last, back up your file systems so that you're able to get your data back in case you accidentally deploy something that deletes a file or deletes a directory.